All right, let's go ahead and get started. I want to welcome you to the third installment of Unit 1. This is matter. Remember, we started with a question, and the question was, what is matter? And we said that matter was anything that had mass and occupies space. So what we want to do now is we want to take a look at a couple of definitions. The first one, of which is one that we're fairly familiar with, and that is, what is a solution? So when you take a small amount of salt, and we're going to call that a solute, all right? So what we're going to take first is the salt, and we're going to dissolve it in a large amount of water. We're going to call that the solvent, and then we're going to stir it a lot. Now, when we do that, the salt ions distribute themselves very evenly throughout the water molecules. Now, salt, or NaCl, is an ionic compound. I should explain that. And by ionic, what I mean is it is composed of charged particles. All right, that's all you need to know for right now. That the ions, or the particles, are going to separate evenly. This is known as a solution or a homogeneous mixture. What about a colloid? Well, this is a mixture in which the solute particles, which are dissolved in the solute, are so small that they're invisible to the eye. However, they are large enough to diffract light. So if you've ever been out, for example, in a heavy fog, for example, and you're driving around, the headlights of the car will shine in a way that illustrates that the fog itself is a colloid, right? Or think of Jello when you think of a colloid mixture. So that's a colloid. Another definition we're going to want to know is something called a suspension. This is a mixture in which the solute particles are large enough to be seen with the naked eye. They are suspended in the solvent, but eventually are pulled to the bottom of the container by gravity. So on the bottom, say for example, on an Italian dressing bottle where the particles are suspended, and it says on the bottle, it says shake well before you use this salad dressing. So a suspension is one, unlike a colloid, in which the particles are large enough that they can be seen by the naked eye, and they will eventually settle to the bottom just by gravity alone. So more in the way of definitions, we want to talk about an element. This is a pure substance which can't be broken down by chemical means, including anything on the periodic table. So if you look up on the wall, you'll see the periodic table of elements. All of those are elements. They include sodium, lithium, aluminum, and oxygen. Sodium, lithium, aluminum, oxygen, but there are many more. So those are elements, so elements are pure substances. We talked about homogeneous mixtures, a mixture in which the components are evenly distributed throughout. These are also known as solutions. So a homogeneous mixture and a solution are the same thing. They can be gases, liquids, or solids. Air is a homogeneous mixture, obviously, because the gases that comprise the air are evenly distributed. Tea is a homogeneous mixture. And metal alloys, such as, well, any type of metal that it makes up, for example, maybe a lamp or something, or an engine block. Those are going to be homogeneous mixtures. Compounds. We've defined compounds. We said a pure substance which can be broken down by chemical means. So remember, compounds can be broken down by chemical means. For example, water is a compound of two elements, hydrogen and oxygen gas. And water can be, or they will form gases when you break them down. So water can be broken down into hydrogen and oxygen by a process known as electrolysis. And I showed you that on the last installment, on the last video. We said that electrolysis was the process by which electrical current is used to break water into its hydrogen and oxygen components. So other examples include carbon dioxide, sodium carbonate, and lithium bromide. All of those are compounds. Some of them are what we call covalent. I'll explain that later. And others ionic. Again, I'll talk about that later. Pure substances, we said, cannot be broken down by physical means such as distillation or filtration. So you can't use distillation or filtration, for example, to separate water from its component, hydrogen and oxygen. So that's a pure substance. Now let's define the difference between qualitative and quantitative. All right, what do we mean by qualitative? Qualitative means, so think of the prefix quality. Qualitative means pertaining to quality of matter. For example, if I say that a rock has a smooth texture, that's a qualitative observation, right? Qualitative means having to do with its quality. quantitative pertaining to some measured value of the matter. If I say that the rock has a density of 2.34 grams per milliliter, that's a quantitative observation, okay? So qualitative versus quantitative, we should know and be able to determine the difference between those. A couple of more definitions. The first is malleability. Okay, this is a term that we use with metals, particularly with metals such as copper, for example. Malleability means the physical property. So malleability is a physical property of a metal which allows it to be hammered without shattering. For example, the copper which makes up a copper pot is said to be malleable because the copper can be hammered into a shape without falling apart. And ductility. Ductility means the physical property of a metal which allows it to be pulled into a wire. So ductility means it can be pulled into a wire. So copper is also considered ductile since it can be pulled into long, thin wire strips. All right? So those are our definitions. By the way, just a couple of pictures of the ductile and malleable ways that are the characteristics, physical characteristics of, say, copper. These copper pots, for example, can be hammered because of their malleable properties. These coins can be shaped because of their malleable properties. And this is copper wire. Copper can be pulled into wires because of its ductility. So those are physical properties. Physical properties. All right. Now what we want to do is we want to get into interpreting matter diagrams. Okay? Interpreting matter diagrams. All right, so here's how this works. It says identify the following as solid, liquid, or gas. We're going to start there, and then later it says determine if the substance is an element, a compound, a homogeneous, or a heterogeneous mixture. All right, so let's start with identifying solid, liquid, and gas. Let's look at the first row, right? In this first row, you're going to notice that all the particles, whatever they may be, are floating in the container, right? They're floating in the container. So that would indicate that all in the first row are gases, right? Because of the fact that they're floating around. The intermolecular forces, the forces that hold these particles together, are not holding them on together tightly enough that they are able to form a liquid or a solid. So they're all gases. But look at this row right here, this second row. Here we have these particles on the bottom, right? Now, they look like a lattice, don't they? They're tightly held together, and they form this very regular shape that's on the bottom of the container. I would guess that this one right here, letter E, is a solid, right? Now, look at this one right here, H. H is to the bottom of the container, towards the bottom of the container, but it's not in that very structured lattice formation. So I would think this would be a gas. So I would call all the ones in the first row certainly gases. This is a solid, and it's not always clear cut, but this is a solid, this is a liquid, and the two center, the F and the G, I would say are gases, right? Those are gases. Let's look at this third column now, or this third row, I should say. Down the third row, we've got the particles towards the bottom, certainly. They're not floating all over the place. But it's not in a lattice. It's not a very structured system. So I would call this one a liquid. I would call this one a liquid as well. Again, not in that very ordered state. So I would call this one right here, I think that's I, and this one right here, this is K. Those are both liquids. Now what about J and L? Well, these are interesting because of the fact that, let's look at L first of all. L has part of it on the bottom and part of it on the top, right? So part of it on the bottom, part of it on the top. So on the bottom, I would say this is a liquid. But what about these? Here we have liquid and gas in the same box, right? I would interpret this as a liquid which is being vaporized or boiling. The liquid is vaporizing. So we have some in the liquid phase, but some of the gas phase. When we have that situation, we call that boiling. Now, J is very interesting because of the fact that we have particles on the bottom that are in the structured state and particles that look gaseous, right? Well, folks, this is a special situation called sublimation. When when solids go directly from solid to gas, we call that sublimation. I would say J is that situation. It would be a sublimation situation. Let's look at H. This row right here. This one would be a liquid, right? This would be a liquid. This is M. This one would be a solid, a very structured state. This is a lattice, so that's a solid. This would be a gas because the particles are everywhere, right? And this one, P, would also be a gas. Let's look at this one right here. This one's a tough one. Is this a gas or is this a liquid? Well, I'm seeing, is this a liquid or a gas? Well, I'm seeing that the particles are spread throughout the container. I would call it a gas. I would say if it was a liquid, it would fall more towards the bottom. So I would certainly call this one a gas, but it could be a liquid. Certainly not a solid. This I would definitely call a liquid because it's not quite ordered, but I would definitely call this a liquid because they're on the bottom. This is a gas, and this is this looks like a liquid to me. Looks like a liquid. It might be a solid, right? Now we'll talk about the particles and how they're arranged. Obviously, we have some darker particles and some lighter particles, and we'll talk about how they're arranged on the next one. So I'll see you on the next video. Thanks. Bye-bye.